What if I told you that you could practically guarantee a top score in your CUET chemistry paper just by mastering one topic? Well, today we are unlocking that exact secret weapon, alcohols. Stick with me through this, and I promise you are going to walk away ready to crush every single question that comes your way. Let's do this. So here's our game plan for today. First, we'll see why this chapter is such a goldmine for marks. Then we'll dive into the physical properties and the all-important hydrogen bond. After that, we hit the essential chemical reactions, test your knowledge with some real CUET-style questions, and wrap it all up with some pro tips to lock in everything we've learned. All right, let's get right into it. Section 1, Scoring Big with Alcohols. Let's talk about why I'm calling this chapter your secret weapon for the CUET. I mean, seriously, how can just one topic make such a huge difference to your final score? It sounds a little too good to be true, right? But trust me, when it comes to CUET chemistry, the alcohols chapter is predictable, it's high yield, and it is an absolute goldmine for MCQs, if you know what to look for. Because we are talking about 3 to 4 direct multiple choice questions coming from this topic alone. In an exam as competitive as the CUET, that is huge. That's the difference between a good score and a great one. This isn't just another chapter to get through, it's a strategic move to boost your rank. So, what kinds of questions are we talking about? Well, the examiners love to focus on these key areas. They want to see if you can predict oxidation products, compare boiling points, and understand the reasoning behind different reactions. But don't you worry, because today we are going to master every single one of these patterns. Okay, moving on to section 2, physical properties. And here's the best part. Almost everything here can be explained by one single concept, the hydrogen bond. If you get this, you've basically understood half the chapter right there. So what exactly is hydrogen bonding? It all comes down to that polar OH group in an alcohol. See, oxygen is super electronegative, so it pulls the electrons toward itself. This makes the hydrogen slightly positive and the oxygen slightly negative. And that creates this really strong attraction between molecules. It's not just some weak force, it's a powerful bond that controls pretty much everything. And this is the perfect example of that power in action. A classic CUET question is to compare the boiling points of an alcohol and an alkane that have a similar mass. The alcohol will always have a much higher boiling point. And why? It's simple. You need a ton more energy to break those strong hydrogen bonds in alcohols compared to the weak little van der Waals forces holding alkanes together. Remember that reasoning. It's key. Now, things get really interesting when we compare different types of alcohols. Primary alcohols have the highest boiling point, then secondary, and finally tertiary. You might think that's weird, but it all comes down to branching. Primary alcohols are like straight sticks. They have a big surface area to stick together. As you add branching, the molecule gets more round, like a ball. This reduces the surface area, weakens the forces between them, and boom, the boiling point drops. This is a guaranteed question, so lock this trend in your brain. Primary is greater than secondary is greater than tertiary. And that hydrogen bond magic also explains solubility. Alcohols can form H bonds with water, which is why they mix so well. But here's the catch. The alcohol molecule has 2 parts, the polar OH head that loves water and the non-polar carbon tail that hates it. As that carbon tail gets longer and longer, the water-hating part starts to take over and solubility just plummets. It's a constant battle between the 2 ends of the molecule. All right, we've nailed the physical properties. Now for the main event, the part that gives us the most questions on the CUET exam. Chemical reactions. Let's master the essentials. Okay, here are the heavy hitters you absolutely need to know. But for the CUET, the 2 that show up over and over again are oxidation and dehydration. So we're going to go super deep on those 2 right now to make sure you're ready for anything they throw at you. Okay, I need your full attention right here. If there is one single reaction you must know inside and out for this exam, it is this one. The oxidation of primary alcohols is, without a doubt, one of the most tested topics in the entire chemistry syllabus. Let's make sure you don't lose a single mark on this. The whole secret to oxidation is the reagent you use. The final product depends completely on whether the agent is mild or strong. If you use a mild one, like PCC, the reaction is gentle. It stops at the aldehyde. But if you use a powerful, strong agent like KMnO₄, it doesn't stop. It pushes the reaction all the way to the carboxylic acid. This one distinction is everything. So let's try it out. Here's a typical exam question. What's the final product when ethanol is oxidized with acidified K₂Cr₂O₇? Okay, let's break it down. Step 1, what's the alcohol? Ethanol is primary. Step 2, what's the reagent? K₂Cr₂O₇ is strong. So does the reaction stop at the aldehyde? No way. It goes all the way to the end, giving us ethanoic acid. See? It's that simple. Next up, dehydration. And for this reaction, the most important thing is temperature. It's a total game changer. You can take the same alcohol with the same reagent and get two completely different products just by tweaking the heat. At a high temperature, 443 Kelvin, you get an alkene. But if you dial it back just a bit to 413 Kelvin, you get an ether instead. The examiners love to test you on these temperature conditions. Okay, enough theory. It's time to put what you've learned into practice. This is where we see if it all makes sense. Let's jump into some exam-style questions. But hold on, before we start, I've got a quick memory trick for you. For oxidation, just remember this little phrase. PCC pauses at the aldehyde, but KMnO₄ keeps going to the acid. See, the P's stick together and the K's stick together. Say it out loud. PCC pauses, KMnO₄ keeps going. It's simple, it's effective, and it will definitely save you in the exam. All right, time to use that trick. What's the final oxidation product of a primary alcohol with KMnO₄? Pause the explainer right now, figure it out, and then come back. Go for it. And we're back. Did you get it? The correct answer is C, carboxylic acid. Why? Because our trick tells us that KMnO₄ keeps going all the way to the acid. If the question used PCC, then the answer would have been B, aldehyde. You see how critical it is to know the difference between your reagents? Ready for question 2? This one tests a different reaction. Which gas is evolved when a primary alcohol reacts with sodium metal? This is a test of their acidic nature. Go ahead, pause here, and give it a shot. Okay, time's up. The correct answer for Q2 is B, hydrogen gas. The sodium is reactive enough to kick out the acidic hydrogen from the OH group, which then forms H2 gas. Awesome job. Now that we've had some practice, let's move into our final section, a super fast revision and some pro tips to help you avoid those common exam traps. Okay, I need you to listen very carefully. These are the 3 traps that students fall into year after year. First, mixing up the products from PCC and KMnO₄. We have a trick for that now. Second, getting the boiling point trend backwards. Remember, more branching means lower boiling point. And third, confusing the temperatures for dehydration. 443 for alkene, 413 for ether. Avoid these 3 mistakes and you are already way ahead of the curve. And here it is, the entire chapter, all the high-yield facts on one single slide. This is your ultimate revision tool. Do me a favor. Take a screenshot of this right now. Seriously, a quick 2-minute look at this table right before your exam is going to bring everything rushing back. It's pure gold. We've covered the concepts, we've gone through the key reactions, we've learned the tricks, and we know the common mistakes to avoid. You are now fully equipped to master any question on alcohols. So the only question left is, are you ready to conquer the next chapter with the same energy? Let me know how you did on those practice questions. Drop your score in the comments below. Be honest. And hey, if you are serious about becoming a CUET topper and you want more of these high-scoring explainers, make sure you're subscribed. We've got so much more to cover. Thanks for watching, and I'll see you in the next one.